So today we're going to continue with ionic naming. Let's review real quickly. We're naming ionic molecules, right? Ionic molecules are always between a metal and a nonmetal. And if we look, I need you to have out your periodic table of ions. If we look at our periodic table of ions, then we remember that metals are anything to the left. Okay, they're all on the left-hand side, and metals all have a positive charge. Okay, they are cations. C-A-T-I-O-N, cation. And then nonmetals, they sit over here, and they all have negative charges. So they are called anions. Okay, so there's two ways for us to think about ionic molecules. Either you can think of them as a metal and a nonmetal, or you can think of them as a cation and an anion that have to come together. All right, so a couple other things we talked about with our last video was that anionic compounds, they have to be neutral. They have to be neutral when we build that compound. Okay, they must be neutral. And so what that means is that our negative charges and our positive charges have to balance each other out. They have to cancel each other out. So if the cation we're working with has a +1 charge and the anion we're working with has a -1 charge, that means those balance each other out, right? And so today we're going to look at what happens if the elements we're working with, or the ions we're working with, what if they don't have exactly the same charges but with opposite signs, right? What if they're not both +1 and -1? What if they have different charges? That's what we're going to look at today. So let's review just a little bit first, and then we'll jump into those. So let's review from last class. If I wanted to build the formula for potassium chloride, let's review a couple things here. Potassium is the metal, it's the cation, it has to come first. Chloride is the nonmetal, which is the anion. It always has to go second. Okay, so let's go ahead and see what the charges are for each of these. Potassium, if you find it on the periodic table, it's in group 1, and it has a +1 charge. Chloride is all the way on the other side of the periodic table in group 17. It's Cl, not Ci, Cl, and it has a charge of -1. So if we want those to bond together to build a formula, a +1 and a -1 balance each other out. And so my chemical formula is just KCl, right? That is the formula for potassium chloride. Okay, so KCl, they go together just perfectly. Let's say I wanted to build a formula for the compound that is called barium oxide. Barium oxide. Well, I need to find both of these elements. I need to find their ions and figure out what charges they have so I can build the chemical formula for that. So barium is Ba. It's found in group 2, which means it has a +2 charge. Oxide is found over in group 16. It has a -2 charge. So if I'm going to build a formula for these, I want to look at their charges and say, do they balance each other out, or do they cancel each other out? And the answer is yes, they do. +2 -2 gives me a neutral, or a 0, which means the chemical formula is just BaO. All right, let's work the opposite direction now. So I'm going to give you the formula, and you're going to give me the written name for that formula. Okay, let's try this. ALP. I'm looking at what this cation is first. It's aluminum. and the cation gets to keep its regular name, aluminum. And then the P that comes after it, it's from a phosphorus atom, but we used P-3. And so we call it aluminum phosphide. Remember, the second element always ends in IDE, or the anion ends in IDE. We also see that on our periodic table here. If I pull up that periodic table of ions, there's phosphide right there. Since we put together aluminum, which is +3, and phosphide, which is -3, that's how it tells us we needed to use the IDE version. Okay, so phosphide there. Aluminum phosphide is the name of that molecule. So now we're going to start looking at compounds that don't necessarily balance out immediately, that we have to do a little work to make them balance. So let's start with building the formula for magnesium chloride. Magnesium chloride. I want to build the chemical formula for magnesium chloride. So I need to go first write out what are the ions that I'm dealing with here. Magnesium is in group 2. It's Mg and it has a charge of +2. Chloride is Cl and it has a charge of -1. So if I were to put these two together just like they are, I would have magnesium, which is +2, and chloride, which is -1. That would leave me +2 -1 equals +1, right? 2 minus 1 gives me +1. So that's not leaving me a neutral compound. It leaves me with a whole charge of +1, which is not what I want. So I can't just put them together, MgCl. It doesn't work like that because it doesn't give me a neutral charge for my molecule. So I've got to go back and readjust how I'm going to put these together. I've got to figure out how many magnesiums does it take to balance the chlorine, or how many chlorines it takes to balance the magnesium. Well, we should see that magnesium has a greater charge, right, at +2. So how many chlorine atoms would it take to balance out that +2? +2 minus 1, I'm going to need another chlorine atom. So that now on my negative side, I have -1 and -1, which equals -2. And so now +2 and -2 would balance each other out. And so if I'm going to put these into a new molecule, I've got 1 magnesium and I've got 2 chlorides, Cl2. MgCl2 is how I would put together the formula for magnesium chloride. Once again, I knew I had to use more than 1 chloride because magnesium's charge is +2. And if I put it together with a -1, that does not give me 0 or neutral, right? In order for it to be neutral, I needed to have 2 of those chlorides that each have a -1 charge to get that to balance or to be neutral. Okay, let's try another one. Let's say I wanted to build a formula for lithium nitride. Lithium nitride. I first got to identify the ions I'm working with here. So lithium is a +1 charge and nitride is a -3 charge. So I want you to be able to look right away and say, well, +1 and -3 are not going to balance. And if I add in another nitrogen or nitride, that's not going to help either, right? Now I've got -6 on this side and only +1 over here. So that doesn't work. So we really have to see which one do I need more of, right? I need more lithiums. I need more positive charges to balance out that -3. So I'm going to add another lithium here. Oops, it's +1. So that total on this side only gets me to +2. When my negatives, I have a total of -3. So I'm still not balanced yet, which means I need even another lithium, right? And so now I'm at +3 on my cation side, -3 on my anion side, which means that is balanced. And so I can build my formula with 3 lithiums, Li3, and 1 nitrogen, so N, or nitride. So this is my formula for lithium nitride. All right, we've got to use the ions here and figure out how do we get those charges to balance. All right, now I'm going to show you an even quicker way to make it happen. Okay, let's look again at lithium nitride, at the example we just finished. Okay, I'm going to do it over here on the side, a different color so we can see how the process is a little different. Lithium nitride, we said, was lithium +1 and N -3. Those are the ions we need to put together. Now, this method is called the crisscross method. Crisscross method. And this works for all ionic formulas, building any ionic formula. What you do in the crisscross method is you ignore the plus and the minus. So I'm going to get rid of the plus and the minus here. And I'm going to crisscross them from a charge to a subscript. So I'm going to go from the top and bring them to the bottom. That leaves me with Li3N1. Okay, I brought this 1 diagonal down and assigned it to nitride. I brought the 3 diagonal down and assigned it to lithium. And so now it leaves me with Li3N1. But we know anytime there is a subscript that is a 1, we can leave it off. So our chemical formula is left at Li3N, which if you look is exactly the same as what we did when we found out how to balance charges and put it together. So the crisscross method works all the time. So whatever method works best for you is completely fine. If you like to be able to make sure the charge is balanced and do it that way, that's fine. If you like to just do the crisscross method, that's fine too. We're going to still show both of them for a little bit so that we can get used to that. But I wanted you to be able to see both. So let's try another one here. Let's try aluminum fluoride. Aluminum fluoride, okay? Aluminum is Al +3 and fluoride is F -1. So let's first do the crisscross method. When we do the crisscross method, we ignore the plus and the minus and we crisscross them down from a charge to a subscript. And so that leaves us with a compound that says Al1F3. But when the subscript is a 1, we take it out. So our formula really is just AlF3. All right, and I want to show you how it works the same way by counting charges. So aluminum is +3, fluoride is -1. If I've got 3 positive charges here, I'm going to need 3 negatives, right? I'm going to need 3 fluorines to balance that out. So when I build my compound, it would be Al1F3, but I know I can leave that 1 off. So those are 2 identical molecules, right? If they both That's how you write the formula for aluminum fluoride, but now we have 2 ways to go about doing it. Whether you like to use the crisscross method or you like to look at the charges, either way is fine. They both work fine. Okay, so I'm going to write a couple up here. I want you to pause it and then go ahead and solve for them. So let's say we want potassium sulfide. give me the formula for potassium sulfide, and then give me the formula for beryllium bromide. Okay, so pause the video here, go ahead and work them out, and then when you're ready, you can unpause it, and I'll have them up there. So potassium is +1, sulfide is -2. If I'm going to do the crisscross method, I get rid of the charges, I crisscross them down, that leaves me with K2S1, but I leave the 1 off, so it just ends up being K2S. With beryllium bromide, beryllium is a +2, bromide is a -1. I get rid of the plus and minus, I crisscross them down, that leaves me with BE1, B2, but I know if there's a 1 there, I leave it off, so it's just BE, oh, I'm sorry, I put B, okay, bromide is BR, so it should be BR2. I'm going to take that 1 away, BE, BR2. All right, let's look at a couple more examples here. I'm going to move pretty much to exclusively the crisscross method because I think that's what most people prefer to use. But let's look at building the formula for aluminum oxide. Let's look at building the formula for aluminum oxide. So locate aluminum in group 13. It's Al, and it has a charge of +3. And then let's find oxide. It is a -2. So when I crisscross these down, I ignore the plus and the minus for a minute, and I take that charge and I bring it down to a subscript. So Al2O3. There's my chemical formula for aluminum oxide. Okay, if I wanted to check that with my charges, aluminum is +3, oxide is -2. So the way we get these to balance is I can't really see right off the bat which one I need to add to. So I'm just going to pick one, right? If I go to adding an aluminum, that now gets me to a total of +6 on this side. But over here, I'm still at -2 because I've got 2 aluminums that add up to +6 and 1 oxide that adds up to -2. And so now I've got to get enough oxides together to equal -6 so that I can balance. So now I've got 1, 2, 3 oxides that add up to -6. I've got 2 aluminums that add up to +6. Those balance each other out. That becomes neutral, and that means my formula would be Al2O3, which is the exact same as what we got when we did the crisscross method. So now I'm going to give you some formulas that you are going to give me the written name for. This doesn't change any from how we learned them yesterday. So give me the written name for these two formulas. So go ahead and pause it and give me the name for those 2 formulas, and when you're ready, you can hit play again. This one I'm looking at the cation, that is zinc, and the anion is oxide. That's it, so zinc oxide. When we go from formula to name, we don't really have to pay attention to how many there are of each or anything like that. We're just naming it exactly like we know how. On the second one, our first ion is sodium. It keeps its regular ending. And the second one ends in IDE, so sodium chloride. All right, the very last thing I want to look at here with naming these compounds is that if we have subscripts, for example, let's say we wanted to build the formula for calcium oxide. So I'm going to find calcium, it's a +2. And I'm going to find oxide, which is O -2. If I use the crisscross method, I remove the plus and minus, crisscross them down. That leaves me with Ca2O2. Okay, so now here's the very last part of this that we need to learn. If we have subscripts that can be reduced by the same number, right? They can be divided by the same number. We need to do that. So 2 and 2 are both divisible by 2, which means we need to reduce them down and give the most reduced version of these, which is CaO. That is our final chemical formula for calcium oxide. Okay, if you were just looking at charges, Ca +2 and O -2, you might have seen right away that they go together 1 to 1, and you would have gone right to CaO, just like we did yesterday, right? These charges balanced. But sometimes when we get caught up in doing the crisscross method, we miss that they should go together 1 to 1. So we have to reduce them down if we see that there. And so CaO should have been our final formula for calcium oxide. So let's look at another one here. Let's say we have scandium nitride. Scandium nitride. Scandium is Sc and it has a +3 charge. Nitride is a -3 charge. We can see right away that they go together 1 to 1, SCN. Or we can crisscross. We take the plus and minus away. We end up with SC3N3. And so we see since both of them have 3s, we need to reduce them down to SCN. Right? It's almost like we're dividing both of them by 3. All right, we're going to try one more here, iridium sulfide. Iridium is kind of an odd one. We don't see it very often, but it has atomic number 77. Look at it down at the bottom there. It's IR, and it has a charge of +4. Sulfide has a charge of -2. If I'm going to put these together to get the chemical formula, I crisscross them down, IR2S4. And so now I want you to see, can we reduce those? Can we reduce those down by the same number? And the answer is yeah, they're both divisible by 2. And so it's almost like we're dividing them both by 2 here. So we would be left with IR1S2. But when there's a 1 there, we know we leave it off. And so here's what our final chemical formula would look like. All right, I'm going to give you some here that you're going to either have to give me the formula or the name based on what I give you. All right, I'm going to give you the name of zinc oxide, and you're going to give me the formula. I'm going to give you the formula for K2S, and you're going to give me the written name. And then on the last one here, you are going to give me the formula for magnesium sulfide. Okay, so you've got 3 problems here. Go ahead and pause the video and get those problems worked out, and then when you're ready, you can go ahead and hit play. All right, zinc oxide, Zn is +2, oxide is -2, and so when I do the crisscross, I ignore the plus and minus. I bring them down, which leaves me with Zn2O2, but I need to reduce those. And so my final formula is ZnO. Final formula is ZnO there. On this one, all I'm going to do is take it and name it. So the first ion I have is potassium. And since it's the positively charged one, it gets to keep its regular name, regular ending. and then I paired it with sulfide, so potassium sulfide is the written name for that molecule. My last one is magnesium sulfide. Magnesium is +2, sulfide is -2. When I do the crisscross, I ignore plus minus, Mg2s2. I need to reduce those down to now be Mgs.